The cosmos maintains a delicate equilibrium, its physical laws constant across vast stretches of spacetime. Yet theories posit a catastrophic potential, the vacuum decay event. Imagine the observation of a nearby star system perhaps 20 light-years distant, where the fundamental constants governing all reality begin an irreversible cataclysmic shift. Initial astronomical data would register an inexplicable anomaly. The spectroscopic signatures of the target star would contort, atomic emissions shifting, then vanishing. This would not be a supernova, nor a black hole's consumption, but something far more profound, the complete dissolution of baryonic matter, its constituent particles ceasing to exist as known. At its core, vacuum decay refers to the universe transitioning from a false vacuum to a true vacuum. Quantum field theory suggests the universe currently exists in a metastable state, not the lowest possible energy configuration. This metastability implies a potential to tunnel into a more energetically favorable state. The Higgs field, responsible for imparting mass to particles, currently sits at a particular energy minimum. A vacuum decay event would involve this field, or perhaps another fundamental field, shifting to a lower, more stable energy state, fundamentally altering the fabric of reality itself within the affected region. Such a transition would initiate as a bubble of true vacuum, expanding outward at the speed of light. Everything within this bubble, stars, planets, nebulae, and all forms of matter and energy would be fundamentally altered, or more accurately, annihilated into a new, unknown state of existence. For observers 20 light-years away, the event's effects would be delayed by 2 decades. Once the leading edge of the expanding bubble reached the solar system, it would appear as a sudden, silent erasure of the distant star system, followed by the complete cessation of all light and radiation from that direction. The initial impact on matter encountering the bubble wall would be instantaneous and absolute. Atoms would destabilize, the strong and weak nuclear forces might cease to function as understood, and the very concept of elementary particles would become obsolete. Life, and indeed all complex structures, would disintegrate without warning. The detection of such an event would trigger immediate, profound scientific panic. Observatories across the globe and in orbit would redirect their most powerful instruments. Calculations would be performed at unprecedented speeds, attempting to model the bubble's expansion and predict the exact moment of its arrival. Data would confirm the inescapable truth. There are no known physical mechanisms to halt or reverse a true vacuum bubble's expansion. Its propagation at the speed of light means no information, no matter, no energy could outrun its leading edge. Any attempts to deploy countermeasures, even theoretical ones, would be rendered futile by the fundamental laws of causality. The only tool in this scenario would be observation itself, humanity's capacity to witness its own impending annihilation, to analyze the precise physics of an existential threat, would become its final, grim scientific endeavor. Telescopes would capture the star system's disappearance as it happens, frame by agonizing frame. The infrastructure of space exploration, designed for expansion and survival, offers no defense against this. Orbital habitats, lunar bases, or even distant probes are composed of the same fundamental particles. The bubble's arrival would render their structural integrity and operational systems instantly irrelevant, dissolving them at the atomic level. The concept of survival logic in the face of vacuum decay is an oxymoron. All biological processes, dependent on specific chemical bonds and stable atomic structures, would cease. The very forces holding molecules together would become non-existent within the true vacuum, leading to an immediate and total disintegration of all life. The system of the solar system, with its carefully balanced orbits and gravitational interactions, would be entirely irrelevant. Planetary bodies, moons, and the sun itself would not merely be destroyed. They would fundamentally cease to be, their constituent particles transforming into something entirely alien to current physics. The transition would not involve an explosion or a flash, but rather a chilling, silent erasure. As the bubble's wall passed through the solar system, the sun would simply wink out, not extinguishing, but rather unmaking itself. Planets would follow, each disappearing without a trace, leaving behind only the expanding void. This event highlights the ultimate fragility of cosmic existence. The universe's fundamental properties are not immutable guarantees, but potentially metastable conditions. A shift in these baseline parameters demonstrates that even the most robust celestial mechanics operate on a foundation that could theoretically be withdrawn. Unlike terrestrial disasters, where survival often hinges on preparedness, shelter, or escape. Vacuum decay offers no such recourse. A supervolcano eruption might devastate a continent. A major asteroid impact could trigger an extinction event. Yet these are events within the known laws of physics, allowing for some theoretical mitigation or long-term recovery. Even the most extreme cosmic phenomena, such as a gamma-ray burst or a nearby supernova, inflict damage through known physical processes, intense radiation, gravitational disruption, or high-energy particle fluxes. While devastating, these events still operate within the established framework of the universe, preserving the fundamental nature of matter. The vacuum decay event fundamentally redefines existence. There is no radiation to block, no gravitational wave to shield against, no physical force to counteract. It is not an attack upon matter, but a change in the very definition of matter and energy itself. The rules of reality are rewritten, not broken. Terrestrial survival strategies rely on the conservation of mass and energy, the stability of atomic structures, and the predictability of physical laws. In a true vacuum, these foundational principles cease to apply, rendering all forms of engineering, biology, and chemistry meaningless. There are no safe havens, only the expanding zone of non-existence. Compared to the slow, predictable changes of stellar evolution or galactic collisions, the vacuum decay is instantaneous and absolute in its effect once its wavefront arrives. There is no gradual cooling, no orbital decay, no gravitational shredding. Only an abrupt, silent transition from existence to a fundamentally different state. The vastness of space, usually a protective buffer against localized cosmic threats, becomes merely a delay. The 20 light-years separating the event from our solar system offered no true safety, only time to observe the inevitable. Distance, in this context, functions as a countdown clock, not a shield. Humanity's technological prowess, capable of manipulating matter at incredible scales, is rendered utterly impotent. From the smallest nanobot to the largest orbital station, every design system, every engineered solution is built upon the very physical constants now being nullified. Its comparison highlights the cosmic scale of such a threat. The collapse of our localized reality would commence precisely as the true vacuum bubble's leading edge intersected the heliopause, the outermost boundary of the sun's influence. This boundary, a tenuous shield against interstellar space, would be the first point of instantaneous, silent dissolution, ushering in the true vacuum. As the bubble expanded inward, the sun itself would meet its end, not in a cataclysmic burst, but through an unprecedented unmaking. Its internal fusion reactions, dependent on the strong nuclear force and the stability of hydrogen and helium, would simply cease. The star would not explode, but rather unravel at the most fundamental level, its mass ceasing to be. Planetary bodies from rocky inner worlds to gas giants would undergo the same process. Their gravitational fields, dependent on mass, would dissipate as matter transformed. The solid rock, liquid oceans, and gaseous atmospheres would not burn, freeze, or shatter, but would dissolve into a state of non-existence within the new vacuum. Every artifact of human civilization, orbital stations, Martian outposts, deep space probes, would instantaneously and completely disintegrate. Their complex molecular structures, meticulously engineered, would become meaningless. The very concept of structure or form would be abolished within the true vacuum, erasing all traces of their existence. The fundamental forces governing the universe, gravity, electromagnetism, and the strong and weak nuclear forces would be redefined or rendered impotent within the bubble. Particles would no longer interact as they currently do. The very constants that define the universe, from the speed of light to Planck's constant, would shift or become irrelevant. This would not be a mere destruction, but a complete phase transition of space-time itself. The region previously occupied by our solar system would become a zone of true vacuum, possibly containing entirely different elementary particles, forces, or even no particles at all. The very stuff of existence would have changed. The entire process would occur without sound, without light, without any form of detectable energy emission from within the bubble. The silence of the vacuum would be absolute, punctuated only by the expanding wavefront of erasure, moving inexorably through the galaxy. There is no decay, only a transformation into an unknown state. The observable universe, as understood through electromagnetic radiation, neutrinos, or gravitational waves, would simply cease to transmit information from within the true vacuum. No light would escape, No gravitational ripples would propagate, and no subatomic particles would interact in a way recognizable to our physics. It would be a region of absolute cosmic silence. The concept of memory or legacy is equally nullified. Any data storage, whether digital or biological, relies on stable atomic structures and electromagnetic interactions. Within the true vacuum, these foundational elements are redefined, making the preservation of information impossible. All records, all knowledge, would be unmade. The universe itself remains indifferent to such a localized, albeit fundamental, change. The expanding bubble of true vacuum would simply become a new, perhaps permanent, feature of the cosmic landscape, continuing its propagation across light years without deviation. Its existence would be a testament to the unpredictable nature of fundamental physics. From the perspective of Earth's final moments, the process would be swift and imperceptible. The first indication of the bubble's arrival would be the instantaneous deconstruction of the atmosphere. Air, composed of molecules, would unravel, removing the very medium of sound and breath, all within a fraction of a microsecond. Following the atmosphere, the terrestrial surface, oceans, and molten core would undergo the same instantaneous transformation. Mountains would not crumble, nor oceans evaporate. They would simply cease to exist in their current form, their constituent atoms dissolving into the new vacuum state without so much as a tremor. The passage of the true vacuum bubble through a galaxy would leave a perfectly spherical void, a region where the known laws of physics no longer apply. This void would be indistinguishable from the surrounding space by conventional observation, yet fundamentally alien, an empty shell expanding at the ultimate speed limit. The collapse emphasizes that the universe's stability is not a given. Its perceived constancy is merely the current state of its quantum fields. The potential for a fundamental shift underscores the precariousness of all existence, reminding that reality itself can be transient, redefined by energies beyond comprehension. The existence of such an event, even if theoretical, fundamentally reshapes humanity's understanding of its place in the cosmos. It implies that the grand narrative of the universe is not a story of eternal laws, but potentially a chapter in a larger, unpredictable cosmic epic where the very rules can change. Before the arrival, the final moments would be defined not by panic, but by a profound silence. The vastness of space would no longer offer comfort or escape, only an extended, unavoidable anticipation of a change beyond comprehension. Observation would become the universe's final passive act upon its own reality. This theoretical event, a vacuum decay, forces contemplation on the ultimate fragility of existence. It suggests that even the most robust structures, from galaxies to individual atoms, are built upon a foundation that may not be eternally stable. The universe's perceived permanence is merely its current metastable state. The cosmos, in its terrifying indifference, offers no resistance to its own redefinition. The vacuum decay, a phenomenon born from the very fabric of quantum reality, underscores the profound limits of knowledge and control over the universe's deepest, most fundamental mechanisms. In the face of such a cataclysmic shift, what remains of comprehension? When the universe itself can unmake its laws, what meaning does human endeavor or cosmic exploration hold? What if the universe's ultimate fate is not a fiery end, but a silent, absolute redefinition into something fundamentally alien?